All right, basic oxides. Basically, we have already discussed acidic oxides. All oxides of non-metal are acidic. How can you recall that? How can you remember that? I've told you, you just need to remember SO2. What do you need to remember? SO2. SO2. Keep SO2 in your mind. All right.
Okay.
Sulfur oxide. Why? This sulfur oxide is the one that actually causes the acidic rain. All right.
Mm-hmm.
It's going to make you recall three to four concepts. A concept of acid rain, a concept of acidic oxides as well. So keep that in mind. Now, if all the non-metals are acidic oxides, it means all metals form basic oxides. All right.
Mm-hmm.
The oxides of metals are basic oxides.
Okay.
Most, most basic oxides, most basic oxides are insoluble in water. The ones which are soluble in water are called what? Hydroxides or alkalis, right?
Mm-hmm.
Right? Only few oxides, the oxides of very reactive metals like sodium oxide, Na2O, potassium oxide, these are the ones with you can just say group 1. Some of the group 1 elements are they readily dissolve in water. And obviously, once they have dissolved in water, they are going to be called alkalis from there onwards. They form hydroxides, right? Similarly, if you look at calcium oxide, which is which is called quicklime. It is called quicklime. All right. It vigorously reacts with water. All right, and it forms calcium hydroxide, CaO plus H2O liquid solid. They give you calcium hydroxide, aqueous hydroxide. Right? Basic
Give
oxides
me
are, sorry.
No, you can continue, but give me 1 minute. I'm still writing.
All right.
Okay.
Hmm. Now, basic oxides are solids at room temperature. All right. Now, why are they called basics? Basic oxide. Why are they called basic oxides? Because they react with acids to form a salt and water only, which is a neutralization reaction. Okay. An example of that is going to be calcium oxide plus, let's say, mm, HNO3, mm, aqueous solid going to give you calcium nitrate, CaNO3 2 plus H2O, calcium nitrate. All right. You can come across many other examples.
Okay.
All right. Next, we have amphoteric oxides. Amphoteric oxides, so, are oxides of metals, or you can say they are metallic oxides. All right. They react with both acids and bases to form salt and water. What does that mean? It means an amphoteric oxide reacts with acid to give salt and water, right? So it means here it is acting as base. And amphoteric oxides, they react with bases to give salt and water. Now it means that it is reacting as, now it is acting as an acid, right? Because the reaction that we are getting with acids, whenever you react something with acids or bases, the reaction, the result is always going to be salt and water. So when the result is a salt and water, it means it is a perfect neutralization reaction, right? It only can take place between acids and bases. So if one of the oxide is reacting with an acid to give salt and water, it means that it is acting as a base. You understand?
Okay.
An example would be, a classical example of such oxides are zinc and aluminum. All right. And how let's look at that. So they are oxides of zinc and aluminum mostly. Let's take an example. We have zinc oxide plus HCl is going to give you, ZnCl2 plus H2O, liquid aqueous aqueous solid. Understand this?
We don't get the part. Can you explain if you go up, you wrote acting as an acid and you put oxide plus base. Can you explain that?
Yeah, what I'm saying is we are talking about amphoteric oxides, right? We're talking about
Yeah.
oxides. So these
Mm-hmm.
amphoteric oxides are actually, they act as a base when they react with acid, or
Uh-huh.
and they act as an acid when they react with base.
Okay.
All right. You can only get salt and water if acid and bases are reacting. This is what I want you to understand. This is what should stick in your
Yeah.
mind, that this reaction is a neutralization reaction.
Mm-hmm.
Producing salt and water is a neutralization reaction. So if it is reacting with one of the ingredients is acid and you get salt and water, it means the other is the base. If one of the ingredient you is already known base and you're getting salt and water, it means another one is going to be an acid. This is what it meant.
Mm-hmm.
You understand?
Yeah.
So you can have an example like this one. Zinc oxide is reacting with NCl and giving you a salt and a water. It means that what does it mean? It means that this is HCl, this is known acid. Everybody has unanimously know that it is an acid. Everybody unanimously knows that this is water. So it means that this zinc oxide here is actually acting as a base. That is why you're getting a neutralization reaction, right? This is making sense?
Yeah.
All right. Similarly, at, if you look here, it's the same zinc oxide and it is reacting with NaOH. And still you get what? And still you get
Sorry.
a base and if still you get a salt.
Yeah.
This is what the salt is going to be like. Plus water.
Mm-hmm. Yeah.
All right. So in a question,
Okay.
it will be told that you are getting salt and water.
Mm.
And this is the neutralization reaction, and neutralization reaction only comes from acid-base reactions. So one of the base is easily spotted. Can you spot any base over here, any acid over here? No. Do you understand this
Mm.
point? Zinc
Yeah.
oxide is actually a base. We know all metal oxides are actually a base, but there are certain metal oxides that act as bases and acids, both of them.
Mm-hmm.
They are called amphoteric oxides. Amphoteric oxides are oxides that, when they react with acids, they act as a base. When they react with bases, they act as an acid. Right?
Mm-hmm.
You understand? Because on the other hand,
Yep.
why are we trying to explain it further? Because we already talked about it that all metal oxides generally are basic, right? All metal
Basic.
oxides are basic.
Basic.
But there are certain exceptions like zinc and aluminum. Their oxides, they act as an acid when they react with base, and then they act as a base when they react with an acid. This is what is called a an amphoteric oxide that does not has its own particular identity, is just varying according to the reactants. You understand?
Mm-hmm.
Another other popular oxides are aluminum oxide, Al2O3. All right, this is an amphoteric oxide. Another is lead oxide.
Okay.
Excuse me. Lead oxide. Okay, if they're going to, if you're going to react them with the base, you're going to, it will form, it will become an acid and it will only make salt and water. That salt needs to be checked upon and memorized, and you should know how to make the formulas of the salt, right?
Okay.
And then the third and the last one we have neutral oxides. Neutral oxides. Some non-metal oxides. Some form neutral oxides. What does that mean? It means It means oxides that do not exhibit they do not exhibit or they do not show exhibit acidic or basic chemical properties. What does that mean? It means if they're going to go under a reaction, they're not going to react as a neutralization reaction. You get it?
Yes.
The example of neutral oxides, water, right? Water, carbon monoxide, and nitric oxide, NO, nitric oxide, carbon monoxide. This is water.
Okay.
All right. Another important part, identification of an oxide. Let's write with white. Identification of unknown oxide. So if you have an unknown oxide, let's say, so there are going to be two things. Either is going to dissolves, or you can say does not dissolve, right? There can be two cases, right?
Yep.
Does not dissolve or react with acid. The one that does, the one that dissolves in water is of two types, basic or amphoteric, right?
Mm-hmm.
Dissolves in acid or reacts with acid. So it's going to be either basic or amphoteric, right? Then you have to see whether it is soluble or insoluble. If it is soluble, then it is amphoteric. Solubility in water, we are talking about water, H2O, right? Here dissolving means in an acid, all right? Dissolving in acid, and this means soluble and soluble in water. So if it is soluble in water, it is amphoteric,
Mm-hmm.
like oxide of zinc, oxide of aluminum. And if it is insoluble, it means it is a basic oxide.
Mm-hmm.
You understand? Because we have already established that basic oxides do not, most of them, they are insoluble in water. Do you understand how we are going to be identifying?
Yeah. Can you give me 2 minutes?
All right. So soluble oxides, it could be soluble, insoluble. So what are we talking about? Unknown oxide. If there is an unknown oxide, how to identify an unknown oxide? So you can, so we have to see if it dissolves in water, it dissolves in acid, or it reacts with acid. All right. Or you can simply say if it reacts with acid. All right. Reacts with acid. If it does react with acid to give H2O plus a salt, it means it is it can be basic or amphoteric, right? If it is reacting with acid, one of the ingredients is acid, one of the reactant is acid. It is reacting with acid, it means it is going to be a basic or amphoteric. So if it is soluble, it means it is amphoteric. If it is insoluble, then it means it is basic. Do you understand the mind map? This map is very important. Okay.
Yep.
Okay. So
Give me 1 minute. I'm taking it down.
if it is if you have a sample of any oxide, and if it does not dissolve or reacts with acid, it means it is acid itself or neutral. Do you understand? It means it is that it means it is going to be acid. So it means it is acidic oxide or neutral oxide. Understand? So now, so we have to see. We know all acidic oxides are non-metal oxides, right? And for neutral, we already know. So if it is soluble, if the oxide, if whatever solution it is, if it is soluble, it means it is acidic. Excuse me. If it is insoluble, it means it is neutral.